So a couple logistics things right out of the bat. First, actually, I haven't done this talk before, so you can just assume I'm a total noob and all mistakes are because it's new. We've given parts of this at OzCon about a year ago when we first released Bless as an open source project. But what I'm back today to talk about is sort of what it means to run Bless and what have we learned about doing that over the past year. And so the thing is, to get there, I need to repeat a couple slides from last time around so that you guys actually know what Bless is. So we'll spend some time talking about that, and then we'll get into the other stuff. A couple other interesting words of note as we get started. I put stickers on the tables because I love stickers. So if you guys love stickers too, feel free to grab one. We got the Bless logo. And I also have a whole ton of other Netflix stickers, so if anyone's into that, come track me down. I've got Chaos Monkey and other fun things. So let's see, one other word of note. I know a lot of people sometimes like to take pictures during the talk. Totally fine if you want to do that, but just as a FYI, the slides are all available online. They're going to be on the QCon website, and I also have them off my personal webpage on a speaker deck page. So they're actually there right now. So if you're savvy enough, you can probably Google them and find them off of my personal page, or you can go grab them later. So there's no need to take pictures when you can have the full res PDF later on. All right, with that. So imagine you walk into work one day and you find this on your computer. This was the case with some people at Sony about 2.5 years ago when the big Sony hack happened. How many of you guys are familiar with the Sony hack? Yeah, so I figure I probably don't need to go into a ton of detail. Suffice it to say, some adversaries got in, and there's a lot of stories online about what people thought might happen or kind of the after effect and all the data that they got out. But the assumption is that these adversaries were actually in their systems for quite some time because they were able to pull out over 100 gigabytes of information. And a lot of the stuff that you saw in the news was movies that got leaked, really sensitive internal corporate emails, financial documents, those kinds of things. Because those are the kinds of things that you would expect to see on CNN. However, if you went over to Reddit, you would have seen a little more information about what got leaked. So the adversaries actually posted README files that indicated here's all the information, here's all the files that we leaked out. And someone thought it would be interesting to grep that for things that might indicate private keys. And they found this.
You might be on the other side of the column, just that the camera actually gets you.
All right, I'm going to be over here. Sorry, guys. So lots of private keys, and as you can see, some of these appear to be either SFTP or SSH keys. Okay, so why would an adversary go after your SSH keys? It's probably pretty obvious. If you want to do movement inside your network once you get in, these are extremely valuable. And it turns out that SSH keys don't get rotated particularly often. A lot of people tend not to put a password protection on their private key. And in fact, I did a little study a while back, and I found well over 50% do not put a password on their private key. We'll just leave it at that. And so they're very, very useful. It's like having a password, except usually it's to even juicier places in your kingdom. And it's not just Sony, right? There's a lot of other places where this has been going on. If I just kind of scroll through a few news articles, you'll see this was last fall. A bunch of embedded devices had their SSH keys leaked so that people could get into them. We had a company that makes PBXs. They didn't actually have a source code problem per se, but someone came in to their corporate network, and their customer support personnel had a whole bunch of SSH keys and other ways to get into their customers' locations to do customer support and service. And so someone got into that network, got that information, and then of course all their customers were put in a vulnerable situation. There was a breach at Expedia, and while it's not clear exactly if they used SSH keys to get around, they certainly got some admin accounts and started walking around with those. And so there's discussions around some of the implications of that. A while back, some folks got some SSH keys from FreeBSD developers and wreaked some havoc on their servers. There was some stolen SSH keys around Linux developers, again, wreaking some havoc. Here's some malware that is specifically going after your SSH keys. This was from a couple years ago, but malware today still does that. So, the point is, There's a lot of these things, right? And this is a very juicy target. This is something that attackers are going to go after as soon as they get into your world. And so this is actually from an RSA blog about how attackers operate. And it's actually kind of nice that I can tee off of the keynote this morning because there was some discussion around the threat that attackers provide. It's interesting that RSA has this really nice graphic for it because, of course, they themselves were the victim of such an attack. So they're a really great place to publish this. They know exactly what it's all about. I found this was a nice overview, so I kind of reproduced it here. I mean, basically, you're going to go in with a phishing attack, which is kind of like what we heard about this morning. Set up some sort of backdoor so you can get into the system. That can be the web shell that they were talking about. That can be any other sort of implant on your system to get in. Then you start doing this lateral movement. That just means you're going to go from one system to another, to another, to another, until you find all the juicy bits within the ecosystem. Sort of a discovery phase. But how do you move laterally? Well, you get SSH keys. You get admin credentials. You get other pieces that allow you to move between these machines. From there, you collect all of your data that you want to get out. You do something to package it up. Maybe you encrypt it. Maybe you compress it. And then you find some way to get it out. Typically, you're going to take it from whatever the organization's network is that you're in and bring it out to some sort of other compromised machine. Maybe take it through a couple hops so that it's harder to trace it back to you. All right, this is how it works. And so those SSH keys become a very important step. So that's fine. It seems obvious. We all need to protect our SSH keys. We can all go home now, right? So everyone's good with that? So what's really the problem here? The problem here is that we also need to use these SSH keys. And so we need to sort of balance the usability around it and the fact that developers actually have a job that they need to do with the fact that we have to protect these things. So at Netflix, we use a tool called Spinnaker for our continuous deployment systems. And here's just an example. Each of these little rectangles represents an instance in the cloud. And what I'm showing here is you've got one rectangle that's red. So when you have a scenario like that, sometimes you want to SSH into that system and figure out what's going on. You know, why is that system not healthy? Well, I'll have a demo later that kind of walks you through exactly how we do this. But bottom line is when you SSH from your laptop into that instance, you ideally should be authenticating to prove that you're someone that's allowed to do this. And how should you do that? Maybe LDAP would be interesting. You can integrate that with SSH. Do any of you guys do that? Couple of hands, okay. I actually was expecting to see more because I've heard a lot of people doing that in the past. We tend to avoid it personally. The reason why we don't like it is because it adds another dependency and another failure point. All right, so if your LDAP service goes down, then craziness ensues. And by the way, if you've ever managed an LDAP service, enough said. And if you're not the one that manages the LDAP service, go talk to your LDAP administrators and ask them about a future world where they don't have to do that anymore and see them smile and all that stuff. It's really great. So, yeah. OK, so no LDAP. So how do we actually do this? Well, if you look at sort of common recommendations, if you go to AWS and say, hey, I need to do SSH, how do you suggest I do this? They're going to show you something along these lines. Basically, as you deploy your instances, you can just have them inject an SSH public key onto each instance. And then each of the operators can SSH in. Seems reasonable enough. The challenge is, if I do that, then that means that there's a private key that each of those developers has. And they need to use that to get onto those instances, right? And so I can either have a different private key for every developer, add up how many developers you have and realize, OK, that's probably not a good idea. I could have the same private key for every developer, and then you fire someone, and that's not a good idea. And so this actually doesn't scale very well. This might work if you have one or two people. But as you get to more, you pretty quickly say, we need a layer of abstraction, because that's how we solve all problems. So we add a Bastion to the picture. And then the Bastion is a great place to put your private key. You have the operators log into the Bastion. They authenticate through some other managed mechanism. Maybe in this case, it could be LDAP, but preferably like SSH keys again or something like that. It's kind of turtles all the way down. But let's talk about what you do from the Bastion to the instances, right? In that scenario, the Bastion maybe is set up to be super secure. So you put the private key on there, and when people log into the Bastion, they can issue some command that will then get them from there to where they want to go. And assuming that the Bastion is always perfectly secure and there's no such thing as local privilege elevation and that kind of stuff, then we're good to go. The problem here is that at the end of the day, that private key on the Bastion is really hard to protect. And it is really hard to avoid local privilege elevations. And if that were ever compromised, then you're in a situation where you need to go touch every single one of those instances that you have deployed to update them to a new key so that you can then roll out new keys in the Bastions. And I don't know about everyone else's infrastructure, but we've got on the order of 100,000 plus instances in the cloud. Even if I have an automated solution to do that, the time window to go through and just smash the whole system with a bunch of new keys is going to be longer than I would prefer to be vulnerable, right? And chances are some of those instances are the old crusty ones that might not have an SSH and I can't get it, or other issues, and so that just becomes a trail of tears. So we stepped back and we said, well, how do we actually make this better, right? Where do we go with this? And we kind of pushed everything aside and said, okay, I need to figure out what properties I want out of the system, and then I'm going to start building a system to create those properties. And when we looked at it, first we're from Netflix, so we get really cool graphics. We said, one of the things that we really want is single-use SSH keys, right? What if I had a very short time life on every key that I issued? I used it once, and then it wasn't valid anymore. So if I lost that private key, the scope of that problem is very, very reduced. Compared to if I lost the private key in the Bastion, it's a very bad day. All right, well, that would be great. What if every time someone used that key, it left really good clues behind, right? So excellent audit trail, nice logging. I always knew what was going on. That'd be pretty nice. I'm a security guy. I love audit trails. And finally, what if it offered really, really strong protections in general, right? What if I could protect this system way more than I can protect the system that I had today? That would be great. I would feel, as a security guy, very comfortable if we could achieve all those things at once. And so that's what we aimed to do. And I'm going to talk about how we got there with this system called Bless. But first, it's probably useful to step back and look at SSH authentication in general. Now, I'm not going to give you a masterclass on protocol security here. And this is intentionally a little bit small. I'm not expecting you to see each of the lines. But the really interesting point here is that this is basically what happens when you do a network connection between a client and a server. And there's a public key authentication happening with SSH, right? So you've done SSH keygen, you've got your keys in place, you set up the connection, and it sends a variety of information back and forth. It establishes a key for your session, and then starting down here, messages are now encrypted, and we go down and we can see all those pieces come together. Now, there's another mode in SSH. Is anyone familiar with SSH certificates? Any hands? Just a couple, okay. So SSH certificates work a lot like the SSH public key mechanism, except now it's a certificate, which means some authority can sign it to indicate that it's valid. And just like you would think about certificates in the browser world, you can have your SSH service set up to trust a particular signing authority, and then any certificate from that authority is allowed into your system. So this works out pretty well. It turns out the protocol is pretty much exactly the same. There's just a couple of small differences, and those differences are highlighted here, and that is at the initial setup, instead of doing that public key, we actually have to get a way to create a certificate, and we have to sign that certificate somehow. And on the server side, we actually need to set up a trust store, like a certificate authority file that says, here's the public key of the certificate, we're going to trust this, and we're going to move forward. Okay. And then all the way down at the place where we actually validate that the session is good to go, of course, we're checking the certificate against the certificate authority instead of the traditional public key thing. And that's it. Everything else is identical. So this is a pretty much battle-tested setup. It's not some sort of esoteric thing, right? This is something we can trust. But the really cool thing is that now we can take those operations, the signing operations on those SSH certificates, and move them to a third machine, right? We can have a separate certificate authority that its sole job in life is to sign these certificates for clients to get into servers. And why I like that so much, and I get so excited as a security guy, is now the private key that is the security of my entire ecosystem is off in some corner that has a single purpose in life. Right? It's not on a Bastion where someone can get to it. I can protect it and defend against it quite a bit better. And so that starts to look really, really nice. And that is exactly what Bless provides for you. So Bless is one of these forced acronyms. Stands for Bastion's Lambda Ephemeral SSH Service. Let's not worry about that. Let's just focus on the logo. Like I said, we have stickers. You can come get them. All right, stickers look just like that. And what is this ephemeral piece? And what is this Lambda piece? Well, has anyone here used AWS Lambda? Good, lots of hands, all right. So AWS Lambda is super cool because you don't have to worry about anything other than the function that you write and you want to run, right? So you don't have to worry about the OS underneath or anything like this. And it just runs this. You take a small bit of code and drop it in, and they'll run it for you. Now, the blessed world, we basically use a Lambda as our certificate authority. And then you have a Bastion that makes a call to that Lambda function saying, here is the public key. I need you to sign it. I need you to turn this into a certificate. And then it returns the certificate back, and then the Bastion can then go use that. And that's super great. Now, the problem is those Lambdas, they actually don't have any persistent storage. And so you need some place to store that private key that you're using to sign everything. And we're fortunate enough that AWS also has this whole KMS service, so you can store your keys in there, and you get a pretty good amount of security on it. So all of a sudden, I don't have to maintain this thing in any meaningful way, and I can have a pretty high confidence that the security of it is pretty good, right? So that's pretty fantastic, and then I come full circle, and once I get that certificate back, I can log into my instances with it. So that's Bless in a nutshell. The rest of the talk, we're going to get into a little more details about how this actually works. But first, let's look at SSH certificates, because I think it's super cool. You can do a lot of stuff with them. This is an idea of what an SSH certificate looks like. You've got a whole bunch of information here that you can use to scope where the certificate can be used. For example, right out of the gate, you can decide if this is a certificate for a user or a host. You can control what information gets logged when someone logs into your service with this certificate. And that's in this key ID field. Now, this is super cool because that means at the time that we're minting this certificate, we can package up a whole bunch of information like who's this user, what Bastion are they coming from, what's the lifespan of this certificate, all sorts of interesting things that you might care to create an audit trail for. You can just bake right into there, and then it automatically gets logged for you. Let's see, we've got the ability to set a time span that these are valid for, right? So if you're using it in the way that we use it, where you have a Bastion and then you're going to turn right around and use the certificate to log into your instance, you can make it good for about 5 minutes. That should be plenty. And then you know that even if that was stolen, it would only be useful in those 5 minutes. But we can actually do even better than that. We can say that when you get onto the instance, I'm going to define a principal, and that principal basically defines what I'm allowed to do when I get onto that instance. So think of this as mapping to specific users or specific operations on the instance that you're going into. And you can pretty arbitrarily do this, so we'll get into some examples of that later. So you can scope it down further there. I can also scope it down further by saying this certificate is only valid coming from a particular IP address, right? So this will only work if you come from a Bastion. Well, that's pretty cool. So if someone steals it and takes it and tries to use it from somewhere else, it won't even work at all. All right, and finally, you can set up all the typical SSH fun that controls your session, right? So you can further scope it there in any way that you see fit. So this is pretty cool. You can do a lot of fun stuff. You can scope these things for a short period of time. Let's talk a little bit about how we would use this. There's a couple ways you can imagine setting this up. A very straightforward way is to say, if my developer can access a particular Bastion, then I'm going to allow them to access any system that sits behind that Bastion. It's the simplest possible authorization policy I can dream up. It's basically wide open. You might have different Bastions for different segments within your world. But if you can get onto the Bastion, then you're good to go. So in this case, Bless doesn't actually have a whole lot to do in terms of deciding additional authorization steps. It's just going to say, if you're on the Bastion, I'll go ahead and cut a cert for you. But you might want something a little finer grain. And this is kind of where we started, and then we kind of realized over the time period that it's useful to have a little more. And so the next step could be something like this. All right, I'm on the Bastion, but maybe I'm only allowed to go to particular apps. Now, I don't want to have a big central repository of every single permission for every developer and every app. So what I can do is just push this all the way out to the instances themselves. and they can set a policy and say, you have to be in this group, or you have to be this user, or something like that, before you can get into my app. Turns out to be a very useful construct. And that way, the information that Bless puts into the certificate can get used instance side in that principal to define who's actually allowed to come through. Now, there are some slightly more complicated apps out there. So imagine a use case where you have a bunch of containers on a particular instance. And those containers have different developers that are allowed to get into each one, right? So we have a little bit of user multiplexing going on here. Maybe I don't want to say, anyone that has any container on there can get onto that host. Maybe what I want to do is actually have further scoping, and I want to say, well, this user can get into some containers, and this user can get into other containers. And so you can actually start to do those sort of richer things, again, using these principles and multiplexing on the host side. All right, so I talk about principles a lot. Here's a example of how we're doing it. And I'll show this in operation later in a demo. But basically, you can imagine putting something like your instance user, your AWS account, your app name. We tend to do like instance ID and a couple other fields as well to just scope this. But it's an arbitrary string. It can be pretty much whatever you want it to be. And once you have that, then you just go in your SSHD on the system that you want to log into. And you can specify the certificate authority that you're going to trust. So that's going to be like the Bless certificate authority. And then you also specify the authorized principals. And that principals is a file. Notice the %u there. That's the user that you're going to map it to. So in this case, if I create a file like this and I call it bless demo, that means there's a user on your Linux box called bless demo. And that user is accessible by people that satisfy the principal line here. So if your principal line says bless demo instances, blah, 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 then you can get into the bless demo user. All right. So let's talk about how we actually use this a bit in operation. First of all, this is the picture that I showed earlier. For those of you that have actually built systems, does this look about right or maybe a little bit simple to you? Who thinks it looks a little simplistic? No one thinks it looks simplistic? All right, you guys are giving me way too much credit. This is what it actually looks like. I had to, of course, abstract things out a little bit. So let's walk through the various flows here. This is sort of like the next layer down, right? So we've got a variety of things. We've got a user on the left here that can SSH into the Bastion. And on the Bastion, we sort of break it down into two different setups. So we've got the user space, which is the tooling that a user will use to access a kernel space daemon. And this user space tool we call Pilgrim. And the daemon on the kernel side we call Shaman. I didn't name them, for what it's worth. So basically what happens is that Pilgrim will call to Shaman, Shaman will call to Bless, and then Bless will do the operation that we talked about earlier. So it calls KMS and gets your certificate signed, and then the certificate comes back, and you can log into your instances. Now what's super cool about all this as well is you can see there's all these things on the right side that show logging happening. And so all of that information can come back in, and you can start to do interesting analytics on your logs. For example, one of the things that we like to do is make sure that no one's using DSA keys. DSA is considered sort of not a good practice in SSH anymore. Everyone should be on RSA. And so this allows us to take all this information, all the SSH logs back, analyze and say, who's using DSA keys? We can say, who's actually logging into my service now? I've got a strong authentication trail with the users. We can look for anomalies in those logins, right? So this user Joe, they're always logging in over here, and that's their cluster. But then today they logged in over here, and that's different, right? And so maybe we don't need to stop them from going there. Maybe they had a perfectly legitimate reason. They were helping out a colleague or something like that. But it's enough that we can send a notice to Joe and say, hey, Joe, was that actually you or not? And then they can just answer, and we can move on with life. But if they answer in the negative, oh, that actually wasn't me, I don't know where you got that, well, then we can figure out what happened there, right? We can look into it. So there's all sorts of fun things you can do. All right. So some of the other benefits that we see out of this. I talked a little bit earlier about this idea of the challenges with everyone having their own personal keys to get into the bastions. One of the issues there is that it's really hard to convince people to update and rotate their keys, right? And so gets to be sort of the human problem of something is compromised, and now I have to walk to a single person and say, I need you to rotate your key. And it's hard to generally protect them. It's hard to convince people to use good passwords on all their private key files. There's just so many challenges around that it'd be nice to just push that aside and not even have that be a situation. We also talked about the shared key challenges where it's hard to protect them on the Bastion. The other thing that's actually really nice about this solution is the expiration. So the keys become very limited in scope, and so you don't have a lot of worries there. We also get some interesting benefits with key rotation. So typically when we deploy it, we don't have just a single certificate authority, a single private key on the certificate authority side. We'll have multiple certificate authorities, and we bake all of those public keys into all of our instances. And one of those is offline at all times. So it's in a safe, tucked away on like a USB key, and no one touches it. That is very much in case of emergency, go pull that out and you can use it. Because if something is compromised, we can start deprecating the old one while we start minting with the new one, for example. So it allows you to do things like this that are actually really powerful in ways that are transparent to the user base. We talked a little bit about the logging. This is some example of the logs that you're going to get out of the system when you use something like Bless. But it's arbitrary. It's whatever you put in that key ID field. So here we have an example where we see the username, we see the IP address that they're coming in from, we see the commands that they're running, which SSH keys they're using, what the validity period is, all very useful information for your audit trails. And of course, there's some availability wins. I talked earlier about our not liking LDAP for this scenario and the reasons why. And in general, we also had this break glass mentality where we do have that offline key where we can get access to the system if we need it. All right, so as with all of the security talks today, there's open source pieces here. And whenever I start to look at an open source projects, I tend to go to the projects page and I start to look at a couple things just to understand, is this a healthy project? Is this something that I'd actually want to use? Here's what I tend to look at, so I thought I'd share it with you. First off, quite a few people have started, so it's got a little bit of a following there, which is really great. That suggests that maybe there's a good community around it. Then I look at things like, okay, how many contributors are there? Are you actually doing like release management? What's your development practice looking like? What's the license on it? It's Apache license, so it's pretty easy for people to consume. And then I start to say, well, okay, that's all fine and dandy. Are they actually doing continuous integration? Do they have good test coverage? Is all this available for me to see? Okay, so that looks good. And then I say, of course, is there documentation? And there is, so great. So this is relatively easy for you all to pick up and use if you're interested. I certainly encourage you to check it out. And we have people back on my team that support this regularly since we use it in-house. And the version that we use in-house is the version that you see in GitHub. We don't have some sort of magical other version. And so we're right there with you answering questions and trying to make this thing better. All right, so let's talk about how this works in demo mode. First of all, I'm one of these people, the demo guys just never look kindly on me. And I'm demoing something that is buried deep within the Netflix ecosystem, which would mean I'd have to go across a network and a VPN. So I decided, you know what, this isn't going to be a good idea. So I've got some videos for you to demonstrate how this works, and that way, hopefully things go. But videos can fail too, so we'll see how it goes. All right, so back to our picture here. This is the whole ecosystem. For the first demo, I want to cover just a couple pieces. So this is the user experience around it. This is how a developer experiences Bless. Going to their instances. Or, as you'll see in a moment, they basically don't have to experience too much of it at all. All right, so we start. Oh, this is going to be really small. All right, we start with Spinnaker. And we pull that up. We go over to one of the instances that we see there. And we say, I want to SSH into that instance. So we click on it. And then you go on over on the right side, and you can click to copy an SSH command. Drop that into your terminal. Type in your private key password. This is going to be the password for your key to get onto the Bastion itself, or however you authenticate to the Bastion. And boom, you are on the instance. So what just happened here, we did one command, And we went from developer laptop through the Bastion onto the instance. A little bit of command line magic. But as you can see there, basically all we're doing is we're saying that we're SSHing and we're running a command on the Bastion to do that next SSH step as well. And that's what our OQ SSH is. That's a tool that will activate the Lambda keys and get you going. So super easy for developers to get onto the instances. It's always step one for me. All right. So next, let's look at how the Bastion uses Bless. So for this, we're going to look at the pieces on the Bastion itself primarily, and then how it interfaces back with the Lambda function. All right. So the left side of the screen is Pilgrim. That's the user space on the Bastion. The right side of the screen is Shaman. So that's going to be the daemon on the Bastion. And what we did is we spun up Shaman on the right so that we had the daemon running. And now we're going to issue a Pilgrim command. And we can provide a variety of things here. The user role is going to be what goes into that principal. And then we can provide things like the ASG, the instance ID, and other information about where we're trying to get to. When we run that, it actually returns the file location for the private key that it generated. And inside there, you're going to have your certificate and your private key and the information that you need to actually SSH in the system. The certificate has all the kinds of information that we talked about before. So we're showing here various request ID information, what the role is that you're coming in as, and the validity dates, all sorts of fun stuff. I know this is a little bit small, but if you go check out the slides online as well, even though I don't have the full videos in there, I have the final version of each video slide, so you can actually see the results of all the commands if that's helpful for folks later. So we've got the command that you want to run when you get onto the instance there. We've got the function that's being run, so we've named our Lambda function Bless, and so we know that's what got called to generate this. You can imagine having multiple Lambdas that you might call, and you might want to log which one they hit. There's our actual validity period. We put the validity period in the key ID just to log that information, but the one that actually gets enforced is the one in the valid field there. We have a principal that will scope it, as we discussed before, with all sorts of information, including the instance ID and the account ID. We believe instance IDs are unique within an account. We're not confident that instance IDs are globally unique. So we included both of those fields to make sure that we had a unique identifier there. Also, if you go back and look on the other side, once Pilgrim runs, Shaman will log information about what it did. So it's actually going to log that fact that Pilgrim ran, who ran it, and it actually pulls information out about the user on the system that ran that command. So it would have your username, and it injects that in. It pulls its network IP address, and it injects that in as well. And it puts all that information together and makes a request to the Lambda function. In this case, we're actually logging the request body. So the whole JSON payload is here too. You could kind of choose what sort of verbosity you might want for your logging. It's the classic trade-off of having a great audit trail versus using up a lot of space. And maybe it depends on how often people are SSHing into your systems as well. All right. Then we've got how do we actually set up this on the instance side? Okay, so the Bastion setup, we saw how it gets used. The instance setup is actually relatively straightforward. We're going to look at the instance itself and some of the log pieces around that. Now, before I start this one, the way that this demo is going to run is going to be it kind of is confusing at first, so I'm going to set it up for you. We're actually SSHing into the system that we're on. So what we're going to do is we're going to set up something that runs across localhost. This allowed us to basically set up something on an isolated system because I didn't want to reveal all of our internal instance IDs and all sorts of stuff as we log through. So that was a nice way to handle that for you. So given that, let's see if we can go. There we go. All right, so what we've got here is the SSH configuration. This is the server-side configuration. At the very bottom, we're going to drop in an entry to say, I'm going to trust this certificate authority, and here's my principals file. Just like I showed earlier with that %u to specify, we're going to pass the user as the file name. We save that out, And then we go actually create the files for those certificate authority keys. Just drop in the key that we want in there. Now, typically, this is where I said you might have multiple CAs that you trust at a given time, just for operational reasons. Then we're going to step into the principals file. Notice, again, the username there. So if someone comes in with the principal that we're going to specify, they would get the blessed demo user on this particular host. And again, we have the instance ID, the account ID, the ASG name, all baked into there. All right, now we just need to restart the SSH daemon. And we should be good to go. So at this point, we're going to start up Shaman. And we have an SSH command. Now notice I'm passing to -i, which is saying this is the private key to use, a backticked command that calls Pilgrim. So remember, Pilgrim actually returns the file name of the private key. This is where that becomes particularly handy. So we just embed it in a single command, and everything will happen transparently for us. Again, to the Pilgrim command, we can specify all these arguments about the role that we want to acquire. And sure enough, when we run it, bam, it logged us in as the blessed demo user. Now, what we can see here as well is we can look at the log output that you would get on that SSH daemon for that user who just logged in. So let's take a quick look at that. Here we go. And we're going to see a log line, accepted public key for blessed demo from the IP address of the Bastion. In this case, it's localhost. And it has all the information that we put in that key ID field. So you get really nice login information there. All right. Last thing I wanted to mention is that there's a lot of other people that are working in a similar space. As we've worked on this project, at some level they've come out of the woodwork, and it's been really fascinating to see what other companies are doing. Lyft actually is using Bless, but they're using it in a slightly different way. They wrote what they call Bless Client, and it runs on developer laptops. And they have separate tooling that allows a developer laptop to get AWS keys. And then Bless Client goes directly from their laptop to the Lambda function and does the kind of operations that I showed you straight off of their system. So that's a pretty cool system. And they have a blog post there that talks all about their system. And I believe they've open sourced Bless Client as well. And they work nicely together. Facebook, and these URLs are intentionally small. I was thinking you might go grab the slides and look at them later if you're interested, because it's a lot to copy right now. Facebook uses the same idea with these certificates and principals to scope themselves. Turns out to be extremely powerful when you're working at a large scale. And Wikimedia actually takes a slightly different approach. They have a special way to use SSH agents to better protect those private keys on the bastions. And so that might be interesting in looking at if you're not ready to go full in with the Lambda function and Bless and that kind of a thing. And that's all that I have for today, and I'm happy to take questions.
Did you any thoughts on actually protecting not just the keys and such, but what about the console and access to the console? Is that something you guys thought about too, or?
Sorry, which console?
The AWS console and the accounts there.
Oh, okay, yes. So I showed pictures of Spinnaker, and pretty much all of the engineers at Netflix, there's actually a few in the room here, maybe they can chime in and nod their heads. We don't really use the AWS console. So everyone goes through Spinnaker. And so we can limit the scope on who accesses the console quite a bit. Yeah.
Other questions for Bryan?
There's one back here.
Where's the question? I'm sorry, I missed it. Oh, there we go. Go ahead.
There seem to be a few other pieces of the ecosystem around Bless. Are those going to be open sourced? Or?
Yeah, like Pilgrim and Shaman and stuff. So we've been thinking about it. The challenge is that those are like really baked into our specific deployment, and they're relatively small. So, so we're trying to figure out if we can find a good way to sort of abstract them out so that they would be meaningful in a more general context, then I'm not against open sourcing them. It's just that we hadn't quite gotten around to that yet. I think Bless is the interesting nugget. And it's actually not huge. It's Python. It's probably about 1,000 lines of code as the Lambda function. So it's not too big, but it's a nice piece and it's very reusable. So that was a good one to open source.
My question is relative to the developer part of the presentation. It seems that the developer is able to access to the server right away, but how can you verify that, for example, I still have connection to that authentication to that? Like, let's say that the rotation happens and I'm not aware of it, right? So somehow I lost connection. Is there a way to verify that? And also, when the SSH keys are regenerated, I also have other SSH keys for other applications that I need to have connections with. So how is that organized on my computer to know, like, where's the SSH key stored and things like that?
Sure. So I'll try to hit a couple of questions here. I'll try to hit them in turn. And if I don't quite get it, come up and grab me afterwards. But in terms of how do you handle connections as keys change and get rotated, our assumption is that if a connection is established, that connection would basically live on forever. So we don't go through and kill out a whole bunch of old connections. If that sits around for a while, then so be it. And then we would rotate the keys, and that would be then a requirement that the next connection that gets started is on the new key system. Right? Does that make sense? And then as far as the keys on the laptop themselves, I didn't really get into it in the presentation here, but I kind of mentioned it was turtles all the way down, right? So I talked about how do you get from the Bastion to an instance. There's an interesting question of how do I get from my developer laptop to the Bastion in a world where all the same problems are going to present themselves. And what we're looking at doing there is we actually have an in-house system that can basically convert a single sign-on authentication, so like a Gmail kind of authentication, to a certificate that sits on your laptop, so a SSH certificate, or it could actually be like a mutual TLS client-side certificate. And so that system would just populate your computer with certificates after you've authenticated, and those certificates would be good for, say, a day or a month or something like that, depending on your policy.
We have time for a couple more questions. Anybody else? Oh, there's one right here.
Do you use certificate revocation to have more granular control about the access time?
So no. The idea with certificate revocation is typically associated with long-lived certificates, where you put it out there and it's good for a year or two, and then something goes wonky in that time period and you need to cut it off. Since we're issuing certificates that are good for like 5 minutes, the value of a revocation system goes down, and it turns out that I feel it's basically just too much complexity to be worth it at this point.
Anyone else? One more? Perfect. Let's
All right.
thank Bryan again.
Thanks, everyone.
Thank you.